Okay, this is the fourth video on this topic in circle, and it's called the arc length, and we're going to show you how to work out the length of an arc. But what do we mean by that, and how do we come up with the formula? Well, here's the circle here, and the arc length, which is this part here in red, I'll just put that a wee bit of red, this is called an arc length, AL. Arc length. Now, to work out the length of this, it's related to the full circle, and it's also connected to the angle at the centre. So if we call this the angle at the centre, x degrees, that's related to the full circle as well. And it turns out that the ratio of the angle at the centre, so if we call it x degrees, this angle at the centre, over 360, this ratio is exactly the same ratio as the arc length, AL, over the full length of the circle, or the circumference, or the perimeter, whatever you want to call it, normally called the circumference. So arc length over the circumference. Circumference for the circle, you should know, is pi r, sorry, not pi r, pi d. So arc length over the circumference, which is pi d. And this is the formula, this is how they're related. And we can rearrange this, changing the subject to the formula. You should have already met that in your studies. So if we rearrange this into arc length, so we want arc length on the left hand side and everything else over on the right hand side. So best way to do it is multiply both sides by pi d. So x over 360 times pi d is equal to AL. Then simply swap all that over. If we swap that over, we get AL is equal to x over 360 times pi d. And that's a formula that you need to know. Now, you're not given that formula in the exam, so that's one of the formulas that you actually have to know about, and you have to be able to learn and keep in your head. Okay, so that's all there is to arc length. So let's look at the type of questions we can get on that. Now, there's about 3, maybe 4 types they can give you. Now, I've got a question over on the right hand side here. I've not put any information on it yet, but it's a typical type question you can get in the exam. So let's make up an angle, maybe 120 degrees or something, at the centre, and let's make the radius 7.3 or something centimetres. We'll call this side A and B, and this is probably one of the easiest questions you could get in the exam. So if I give you part of a circle there, and I ask you to work out the length of A to B, the arc length, how do we work that out? Well, quite easily, we take the formula that we just showed you, we write it down, plug in our numbers, and you just work it out. Okay, so these things are normally in the exam, and it's normally calculator exam part of it, so paper 2. You can get it in paper 1, but if you do, then the numbers will be nice and easy, and they normally tell you to work with pi being 3.14, but most of the time paper 2. So this one will be a paper 2 question, and this is how we go about it. So the arc length from here to here, write down the formula. AL is equal to angle at the centre over 360 times pi d. It is as simple as that. And we plug in our numbers. So that's going to be 120 over 360 times pi. Now d, we don't actually know yet. This is the radius, r for radius. So we have to double that. So if we double that, that'll be 14.6. And we just work that out, and don't forget our units are going to be centimetres because it's a length. So let's just work that out. So actually a third, 120 over 360 is a third, and if we times that by pi, times it by 14.6, we get an answer to 2 decimal places of 15.29. And there you go. Normally maybe 3 marks in the exam, one for the formula with the numbers plugged in. Usually get a mark for knowing to use the diameter, i.e. doubling this value, and then your overall mark for the answer. Okay, so nice wee simple one. Let's look at something a wee bit harder. So I'll just draw out an arc and we'll look at something that's slightly more complicated. So again, your arc can be any length, so let's make it not as wide. And just get my ruler. And up there. And up here. So that's my centre of the circle. Remember, just think about the whole circle. There's P. I'll call this R. And C for the centre. And what can we work out then this time to make it a wee bit harder? Well, let's think about, certainly not the arc length. We'll probably be given the arc length this time. Could maybe give you, let's say, we'll make this 20 for the radius. So let's give you an arc length. And we'll make that, say, 28.6 centimetres. So we know that length this time. So this time we could ask you to work out the degrees. Use the degrees in here. That's what we have to work out. So what's the angle of this arc? What's the value of the angle? Well, this is certainly a harder question. This would be probably an AB level, because it's called a working backwards question, and you're given the arc length this time. So you have to rearrange the equation and get the value for x. So arc length. Well, we've got it already over there in the formula. So that's x over 360 times pi d. Now, I would encourage you to be able to rearrange this equation without putting the numbers in. You can put the numbers in, and it's fine to put the numbers in and work it through, but mathematically, your maths gets better if you can rearrange the subject to the formula. And you're going to be asked that type of question in the exam anyway. So you may as well use this to help you to practice changing the subject to the formula. So we need x equals the rest. So this is how we go about it. If I multiply through by 360, I get 360 times AL is equal to angle at the centre times pi d. Now I don't want pi d here, so I'm timesing through x times pi d. So to get rid of timesing by pi d, we divide by pi d. So that's going to be 360 times AL all over pi d equals x degrees. And then we just swap that over to get our formula. Okay, just take the time with that if you're not sure, but I would encourage you to practice it. Okay, and this, when we shove in my numbers, will give us the angle at the centre. So that's going to be 360 times, well, we were told that length is 28.6 all over pi. Diameter this time, well, the radius is 20, so remember to double that, it gives me 40. And we just work that out. So a rough calculation, I think that into that, that's 9 divided by 3, I'm going to divide by another 3, it's going to be quite a low number. So let's see what we get. 360 times 28.6 divided by pi and divided by 40. Gives us an answer of approximately 81.9, and that's degrees. So you could maybe take that that to 82, but 80, 81.9. Okay, and that's a harder type question in the exam A level. So what else could we ask you? Well, we've got the arc length, we've got the angle at the centre. Could ask you for the perimeter. So let's do one with a perimeter in it. So let's draw another arc. So we can find for you. So let's make the arc a wee bit different this time. We'll just do a horizontal line and from the horizontal. Let's go down a wee bit. And from there, let's see. That'll be the centre here, I suppose. And here. And I don't want to make it too much like 90 degrees, so we'll move that a wee bit. And we'll do about wee bits here. Right, what angle can I make that? Well, I don't know, that looks about 70 or something like that. So let's put 70 in here. And let's keep the numbers simple. Maybe 5 centimetres. And we'll call this O for the origin, if you like, or the centre. We'll call this, just call it A and B again, I think. So, let's work out your perimeter for that shape. So you're given that information there, and the question is to work out your perimeter. Now, when this comes up in exam, fairly regular, and when it does come up, lots of people don't actually finish the question off. They work out the arc length, which is the curvy bit, but the question asks for the perimeter, so it's not just the curvy bit, it's this bit here as well, and this bit here as well. So, perimeter. Well, if I start here at the centre, if I go up here, well, that's going to be 5 centimetres. So let's just do the maths first. So that's going to be the radius plus, so that's that part there, and then the arc length plus another radius down here. You've got a radius and a radius. You could just call that the diameter if you like, but we'll just keep it like that and keep it nice and simple. So the arc length, let's work that out first. Angle at the centre over 360 times pi d. That's going to give me 70 over 360 times pi. D is 2 times the radius, which is going to be 10. So we just work that out. So let's work it out. So that's going to be 70 divided by 360 times pi times 10, the diameter. That comes to approximately 6.1 centimetres. So that's just that length, that's just this curvy bit. So the overall perimeter is going to be 5 plus 6.1 plus 5, which comes to an easy 16.1 centimetres. Okay, so that was the perimeter this time we were asked to work out. I suppose we could be asked to work out the radius of a circle or a sector, if you like. So maybe try one of these. Let's wipe that away and we'll work out the radius of a circle. So let's see, let's draw something else in. Let's draw one up the way this time. Centre's round about there, so let's put it in there. Get my ruler. Let's use D, E and F this time. And let's call the angle at the centre there again, I don't know, 60 degrees maybe. not 60 degrees. And the arc length, we'll call the arc length, I don't know, 32 centimetres. Okay, so round that way is 32 centimetres, and we've got to find the radius of that arc. Well, write down my formula. Arc length is angle at the centre over 360 times pi d. Now hopefully you'll know that the diameter is twice the radius, so if we work out the diameter and then we just half it, then we find the radius. So we know the arc length, we're told it in the question, 32, angle at the centre 60, so we can work out d, the diameter. So let's rearrange it again, multiply through by 360. That gives me AL is equal to angle at the centre over pi d. Now we don't want this bit here, we don't want the x and the pi in this side, so we're multiplying here. So we divide through by x and pi. So we get 360 AL over x pi is equal to d. Swap it round, so d then is equal to 360 AL over x pi. Put the values in, 360 times 32 over 60 times pi. And working that through, d is equal to, well, 360 times 32 divided by 60 divided by pi. That gives me 61.1, and that's centimetres. So next wee bit, the radius then must be half of that. 61.1 divided by, well, not use the division symbol, prefer to say over 2, and that gives me a value of 3, 0, point, let's do that calculator, make sure we're right, 30.55, and that's centimetres. Okay, and that's it. I think I've covered every type of question you could get asked in the exam. And that's this video sorted. The next video is going to be area bisector, and it's very, very similar to what we just did there. The questions are very similar. The only difference is the equation. The equation's slightly different. It looks like that as well. It looks like that format, but it's not quite the same. But it's very similar. Okay.